Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert training. I'm your host, Leandro Mod, and in this video what we're going to see is how we can use the digital inputs of the PLCs. Okay, so in my particular case, I have a Modicon M258, okay, that I'm going to use the embedded inputs in order to receive the signals coming from the outputs from the M258, okay? But you can use any other kind of signal coming from a different sensor that indicates true or false, okay? So let's go to the software and see what we have. Okay, so this is the application, and here on the device tree, okay, we should be able to see the hardware part. Okay, we have, if you're using the M251, then you don't have any inputs associated, so you need to add the TN3 modules. So you just need to go to the IO bus, select this one, and you should be able to see this and select the TN3 that you want. Okay. If you have M241 and 262, then you have already some IOs already embedded. So let's talk about the digital input. So digital input, double click. In this particular case, it has some features related to the high speed inputs, but I'm not going to talk about it. So I'm going to direct it to the IO mapping. So in the IO mapping, by default, we have this. So it's divided by a byte, so it has a byte with information of the IO, okay? But if we don't want to, we just assign a name here, okay? So it's gonna be IX push button, and work with this in the code, okay? So if I add, for example, a new POU, right click, add object, POU, SR inputs, and let's do ladder. Here I just add the contact in the question mark here, and you should be able to find on the IO globals my digital input, and I forgot the names here. Global mappings, I should find this IX push button, which is fine, and that's it. Okay, another way to access to the inputs will be to use this one, IX 0 dot something. So you can use percentage IX 0 dot 0. It's going to be the same as this one, and you can see this one is in violet or a little bit pink, so it means that you are using addressing. Another way, I believe, that's it. So we should the addressing, and I believe I should go through here. Let me see if it works. Dot 0, but I believe, no, I lied to you on this one. Yeah, no, don't go into that one. I'm mixing things. So this one is the direct definition on the digital input, okay, which is fine. Another way to do this is, okay, so I'm going to create GBL underscore IO, and here we have the possibility to define, I don't know, for example, IX push button run, okay? So now what we need to do is to link the digital input. So let's put this one to the application GBL.io push button. As soon as we do this, this is not going to be longer available. Okay, it's just delete the address and go directly into that. Okay. And I believe this is a good way because it can be independent on the actual position per se. So imagine that you just define a different name. This is going to be stuck here in this position. You just remap the IO to a different location. Okay, so that's why I think it's much better, but it's up to you. how you want to do it. So we have those two ways, okay, to do this. And here I have this in the position number 1. Okay, so don't worry. Okay, so I got this. It's already defined. We can use it in the code. It's fine. Okay. If you're using the GBL part, then you just need to go here, click the 3 points, and go to the GBL and select the GBL. That's it. Okay, so it's fine. Now, and here you can execute your code, and then you can put it in another place. But something I have done is to have some kind of filter in the middle. Okay, so imagine that, for example, you have this push button that's going to be, I don't know, normally open. But imagine that the push button sensor is damaged, and the only way that you have to replace the damage is to use a different sensor, different contact, like instead of normally open, normally close, or the different sensor, normally open, normally close, normally open. Then you will need to change this in your code, okay, and reuse this variable in all the code. That's why I have some kind of filter and use this one, this variable over here, to do the things in my code. Okay, so that's how I usually do. Then the other thing that I have is this function block that I have created on the library. So if you go to my library here on general purpose signal conditioning, we have FB signal digital IO. Okay, that basically, I'm going to explain it. Okay, so I'm going to add this here. Oops. Oh, that's how it looks like now. Okay. Conditioning, digital IO. Continue. Come on, you can do it. Digital IO. So this one's going to be instance. Digital input 01. Okay. And what it does is I need to enable the signal. Okay, so this one's going to be always true. Let's just put a true here. This is the signal coming from the push button or for the digital IO. It doesn't matter how you want to use it. You can use it like this or percentage IX 0.0. It doesn't matter. Okay. And then you just need to define if it's going to be normally open or normally close. Normally open is going to be false, and if it's normally closed, it's going to be true. Okay, you can change this. In this case, I'm going to leave it like that without any connections, so there I can show you how it looks like later. And here we use the part if you want this to be in the maintenance mode, and then the value for the signal in maintenance mode. Okay. And then here we have assign a name. So this is going to be push button run. Okay. This is going to be digital input 0 on the M262 signal to run motor. Something like that. Okay. Got to use this to run. Okay, so additionally with this, this is going to be my logic. Could be, for example, I usually use MIX input X dot push button. Something internal, doesn't matter right now. So this is the output, is going to be the signal for my program. You usually locate this in a GBL as a mark, the filtered value to use in my code. And then I have the maintenance signal. So if you have an alarm, you can put this output on the alarm, so just to indicate that you are forcing a value in a way. And then if you want additional signals, it could be the rising edge or the falling edge for the same signal you have here, in case you want to. So now I got this, okay. Additionally, what we can do is to, oh, I spotted it. So we can add from the library this signal, VSU frame digital signal, that basically it adds, come on. Oh, it's in the screen. It adds, as soon as you add it, it will ask you to link that visualization frame to an instance. So I have created the instance, is in the SR input, enter, okay, and now it's linked to these things, okay. So let's give it a try. So I'm going to connect to my M262. Let's see if everything's in the same network. Okay, it's fine. It's connected. I believe it's connected. No. Okay, there we go. Now it's connected. Administrator. It's going to be automation 1, I believe. Okay, good. So now I'm going to download this code into this M262 so we can try and see how it looks like. This is one way just to work with digital inputs. Okay. One important thing is there are 3 ways you can use direct access through here or use this to a GBL. Okay, so there we go. So this is the function block, and it's not working because I didn't call it. SR inputs, call it here. I'm going to do this POU from there. Alt F, yeah. Want to change? Yes, don't worry. Okay, so while this is downloading, okay, there we go. So the signal here, I believe, is connected to this digital input, digital output. Digital output, let's see how it's 0 to the 0. Okay, I'm gonna use the watch expression. Oops, watch expression. This is going to be percentage Q x 0.0. Okay, and I believe everything goes well. Should be able to. No, it's not going to do this one. Percentage Q x 0.1. It's not going to help. Is the position number 3? That's because I don't want to get up and see which one it is, guys. Okay, it's a 3. Yeah, so the output number 3 or 0, 1, 2 is the one is connected to digital input 1 on the M260. So at the moment you can see here in the logic that it works using the direct symbol, which is fine. Or what we can do is to assign this we're going to assign that GBL So I'm going to remove this one from here and assign the application GBIO on this one. Okay, just to show you that I'm not lying to you. Okay. Okay, you can see that I have the signal and I have something here. Now, let's have a look into the visualization. Here you can see that I have the push button run. You just take this information from here and put it on the visualization. Use the input 0 on the M262 signal to run motor. The value is true. The function block is enabled. Digital input raw value is true. The input type is normally open, so I can change this to normally close. Okay. The value in the program is false, so you can change this in case you want to. Okay. As you can see, this is the value that I use in my program. Then, if you want to use the maintenance mode, right now is disabled. Okay, you can see that this one is false. I can change the signal for the maintenance. So I will go back here, disable, enable, everything turns on. The output for maintenance is true, so this one you can use it to a combination of alarms if in case you want to, just to have an indication on the HMI that you are in maintenance mode and you shouldn't or leave with this on, because it's just for maintenance, just for commissioning. And then I'm going to change the value true. Okay, doesn't take into account these normally open, normally close. And here you can see that I changed the value for the input and it just followed the maintenance mode that I want to. Okay, then I can disable this. I go back to the value. I go back. So this is useful when you are in commissioning mode, just to test something, to check the logic, to check if you received something. You got it. Okay, so this is very easy. I already showed you how to use digital IOs. This is the library, and the library you find the general purpose for signal conditioning. Digital input is the one I show you. Okay, it's very straightforward. You also have the digital output, but I'm going to explain that later. So this is how you can use the digital inputs on the M262 embedded, or it's going to be the same for the M241. Or if you want to use that on the TN3 IO module. Okay, so thank you very much for watching this video. I'm going to leave on the comments the library. Okay, so thank you very much for watching this video and see you on the next one.